Day 1, Section 3.1, page 177, numbers 1 through 27. Okay, number 1, negative 2/3 x is less than 6. Okay, so there's a number of ways to do this, but I think the easiest way is to do this in one step by multiplying each side by the reciprocal. And because we're multiplying by a negative, this inequality is going to flip directions. So you're going to get x is greater than, and then we'll cancel. 2 goes into 6 3 times. 3 times 3 is negative 9. So we have x is greater than negative 9. Now when we write our graph, we'll put negative 9 in the center, and we'll put a parentheses. If it was a greater than or equal to, we'd put a bracket, but that's for a greater than or equal to. But it's just a parentheses, and then it's greater than that. Okay, number 2. Negative 5x minus 4 is greater than or equal to negative 11. The first thing we're going to do is bring our negative 4 to the other side by adding it. And we'll get negative 5x is greater than or equal to 15. And then we're going to divide by negative 5 on each side. Because we're dividing by a negative number, the inequality is going to flip directions. And 15 divided by negative 5 is negative 3. So we put negative 3. Now because it's a greater than or equal to, we use a hard bracket, and it's going that way. Okay, number 3. 6a plus 3 over negative 4 is less than negative 3. So let's get rid of this negative 4 in the denominator first by multiplying each side by negative 4. Because we're multiplying by a negative, this inequality is going to flip directions. So it's going to become a greater. And negative 3 times negative 4 is a positive 12. Now let's move our negative 3 over to the other side by subtracting it. And we'll get 6a is greater than 9. And finally, we'll divide by 6 on each side. So we'll get a is greater than, we're dividing by 6. So a is going to be greater than 9 over 6. Or in other words, a is greater than 3/2. So on our number line, let's do it in black. On our number line, we're going to put 3/2 in the center. And I'll put a parentheses, and we'll do it that way. Okay, number 4. We're first going to get rid of this negative 3 in the denominator by multiplying each side by negative 3. And because we're multiplying by a negative, the inequality is going to flip directions. So it'll become a less than. And negative 3 times 3 is negative 9. And now we'll move our 5 to the other side by subtracting it. And we're going to end up with 9x is less than negative 14. And finally, we're going to divide by 9 on each side. And we're dividing by a positive number, so the inequality is not going to flip directions, but we'll end up with less than negative 14 over 9. Now that's a simplified fraction, so we don't simplify that any further. We put our negative 14 over 9 in the center of the number line. It's a less than, so we're going to use a soft parentheses, and it's to the left. Okay, number 5. What we want to do first is, I would say let's get rid of the parentheses on the right. So I'm going to distribute this negative sign in here. And that's going to give us 5 minus 6 plus 4t. And then I'm going to combine like terms on the left. The 5 and the negative 6 become negative 1. Okay, now I'm going to move my negative 1 to the right-hand side by adding it. And I'll move my 2t to the left-hand side by subtracting it. And that's going to give me 4t minus 2t is 2t. I'm just moving terms so that inequality is never going to flip. And negative 7 plus 1 is negative 6. Now I'm going to divide each side by 2. I'm dividing by a positive number, so the the inequality is not going to flip. But negative 6 divided by 2 is negative 3. So on my number line, I'll put negative 3 in the center. It's a bracket because of the equal sign, and it's a greater going to the right. Okay, number 6. Negative 6 less than or equal to 2k less than or equal to 24. I want to isolate that k. I can do this all in one step. So I'm going to divide everything by 2. And I'll get negative 3 is less than or equal to k, which is less than or equal to 12. This is a compound inequality. It's two inequalities put together. We can just put our negative 3 here, our 12 here, a bracket because the k is greater than the negative 3, a bracket because k is less than 12, and it's including everything in between them. So that's how we graph that. Okay, number 7. So we want to get rid of this. We want to isolate the 3x in the middle. And so I'm going to move my negative 1 to each side by adding it. So I'll add 1 to each side. And I'm going to get 9 is less than or equal to 3x, which is less than 15. And now I can divide everything by 3. And I'm going to end up with 3 is less than or equal to x, which is less than 5. So when I draw this on my number line, this is another compound inequality. I put 3 here and 5 here. X is greater than or equal to 3, so this is going to be a bracket facing to the greater. But it's less than 5, so it's going to be a parentheses on the 5, and then I just join it like that. Okay, number 8. Negative 4 less than 3 minus 2z less than 9. So the first thing I'm going to do is bring this 3, I'm going to isolate the negative 2z by subtracting this 3 from each side. And that's going to get me negative 7 less than negative 2z is less than 6. And now I'm going to solve for my z by dividing by negative 2. Because I'm dividing by a negative number, my inequality is going to flip. So I'm going to get a positive 7 halves, because that's negative 7 divided by negative 2. But this will be greater than, and this will be z, and this will be greater than negative 3. You always want to start from your lower number first. So I'm going to rewrite this as negative 3 less than z less than 7 halves. And when I graph this, I'll put negative 3 here first on the left, and a positive 7 halves here, and these are both less than, without an equals. That's a z greater than negative 3, and this is a z less than 7 halves, and I'll join it like that. Okay, for number 9, we got a word problem. We're dealing with a rectangle, and so I'm just going to draw this rectangle out. It's a basketball court, it's a playground, and it says that the perimeter must be no greater than 120, and the width is 22 meters. But we don't know what this side is. But we do know that there's 4 sides in a triangle. There's 2 widths and 2 lengths. So if we take twice the sum of these things, now it's got to be twice because we want to include all 4 sides, this can be no greater than. In other words, it could be less than or equal to. That's what no greater than means, 120. So a lot of ways to do this. You could distribute the 2. I'm just going to divide each side by 2. I want to keep my number smaller. And this will be 60. And then I'm going to subtract 22 from each side. And I'll get x is less than or equal to, is that 58? 38. So that means that the length can be no more than 38 meters. Make sure you include the unit meters. Without it, we don't have a complete answer there. Okay, number 10 is a word problem talking about what's the maximum number of tickets that this group can purchase. So why don't we start with that? We'll say that X equals the number of tickets purchased. All right. The group rate is $89 per ticket, and they qualify for a $50 group discount, and they only have $2,000 to spend. So that means that they can spend at most $2,000. It doesn't mean they have to spend $2,000. So what we'll do is we'll say 89 tickets times the price. $89 times the number of tickets, that's the price that they're paying for all of the tickets, minus the $50 discount. This has to be less than or equal to, meaning no more than $2,000. So that's our equation. We're going to start by adding 50 to each side. And we'll get 89x is less than or equal to 2050. Now I'm going to divide, I'll use a calculator, and I'm going to go 2050 divided by 89 is equal to, x has got to be, oops, where am I? Let me erase that. X is less than or equal to 23.03 whatever. Okay, now here's the thing. We cannot buy a fraction of a ticket. So if x has got to be less than 23 point something, really x has got to be less than or equal to 23. So we can buy at most 23 tickets. Okay, number 11 is talking about an average. Remember, an average score is you just add up all the scores and you divide by the number of scores. So we're going to say that x equals to the score on the 5th test. Now, if we add up all the scores, we're going to take all of the scores that were given, 75, 79, 64, and 71, and this final score, and then we're going to divide by the number of scores we see. 1, 2, 3, 4, 5 scores. This average has to be at least. At least means greater than or equal to. So it'll be 70 or more. That's what at least means. Okay, so now to solve this, I'm going to multiply each side by 5. And that'll get rid of that denominator. That'll cancel these. And so I'll get all of this stuff added up. I'm going to use a calculator and I'll just add this stuff up. 75 plus 79 plus 64 plus 71. I get 289 plus x. This is greater than or equal to 5 times 70 is 350. So now I'm going to subtract my 289 from each side, and I'll get x is greater than or equal to 61. So this tells me that this student needs to get at least 61. So at least a 61 on the 5th test. Okay, for number 12, I'm not going to show all the work, but the student did all the work correctly and got to a point in the problem where they got -8 is less than -13. Now, the variables disappeared, and this is a false statement. -8 is not less than -13. So all the x's disappeared, and you're left with a false statement, that means that this was a no solution. There's no x that exists that will make this false statement true. So we have no solution. Okay, number 13. We have, the question is, we want A intersect B. So these are only the places where what the items that A and B share in common. So it looks like we have an A in common and a C in common, but a C in common, but that's it. So this is going to be equal to A and C. Okay, number 14, we're looking for A intersect C. So we want the places that A and C have in common. So it looks like they both have an A. There's no B in both of them. There's no C. There's no D. So just A. So this is equal to just A. Okay, number 15, this is, we're looking for B union C. So that means all of the elements of B and all of the elements of C together. And we'll put them in order. So this is going to be, it looks like we have an A, a C, there's no D, but they do have an E, there's an F, and there's a G. So that's all of the elements that show up in either B or C. It does not have to show up in both. Okay, so number 16 is A union C. The items that show up in either A or C, they do not need to show up in both. So we're looking at, let's see, we have an A, we have a B, we have a C, we have a D, we have an E, we have an F, and we have a G. That's showing up in one or the other at least. Okay, number 17, we have X is greater than 4 and X is less than 7. So if you were to look at a number line, and if you put the numbers in order, 4 always goes to the left of 7. Okay, so greater than 4 looks like that. Less than 7 looks like this. And we only want to include the portions that they share in common because it's an and. So I'm going to clean this graph up because I cannot have those lines running where they shouldn't be. I'm just going to have this. Only the portion that they have in common, and that's my answer there. If I was to write this as a compound inequality, I would write 4 less than X less than 7. In interval notation, we're going to write this like this. We're just going to include a parentheses 4 and a parentheses 7. This is interval notation because we have a parentheses here and a parentheses there. Okay, for number 18, we're starting with X plus 4 is greater than 12 and X minus 2 is less than 12. I'm going to solve this first one by subtracting 4 from each side, and I'll get X is greater than 8. And I'll solve the second one by adding 2 to each side, and I'll get X is less than 14. So if you think of this on the number line, you have 8 first, and then you have 14. Less than 14 goes this way. Greater than 8 goes this way. Because it's an and, I only want the portion that they have in common, so I have to simplify this graph. And you can do this without writing your practice graph, but your final answer, if you graph it, needs to be this here. Now, if we were to write this in interval notation, we would write it like this. A parentheses, 8, 14, and a closed parentheses. This is interval notation. If you wrote this as a compound inequality, you would write 8 is less than x is less than 14. That's a compound inequality. Okay, number 19, we start with x is greater than 5, and we have an or. X is less than or equal to negative 3. So if we were to sketch a quick practice graph, we'd put the negative 3 here to the left of the 5. Now, greater than 5 looks like this. Less than 3 looks like this. If this was an and, we'd have a null set. But it's an or, so we need to include anything that is involved in the graph. And so actually, this is what our final graph will look like. You don't have to put it in separate colors. If we're going to do it in interval notation, I first do this interval, which is negative infinity. Notice infinity always has a parentheses, never a bracket. All the way up to negative 3, and I use a parentheses because we had a parentheses there. And then I union this with 5 to infinity. And again, infinity always has a parentheses. So this is interval notation. And if you wanted to write this as a compound inequality, you would write x is less than negative 3 unioned with x is greater than 5. This problem wants you to write it in interval notation like this, and they want you to graph it. So those are the two forms of the answer that would be acceptable. Number 20, x is greater than, just greater than, let me undo that, than negative 2, or x is less than 2. So when you graph this, we always put negative 2 to the left of 2. It's greater than negative 2 or less than 2. Now, that's just a practice graph. So when we draw this, if we were to graph it, notice that there's something covering every portion of the graph. So we simply do this. We put our answer like that. It's showing everything. And in interval notation, we say it goes from negative infinity all the way to infinity. That's because of the or. Okay, number 21, x minus 4 is greater than 6, and x plus 3 is less than or equal to 10. I'm going to solve this on the right by adding 4, and I'll get x is greater than 10, and I'll solve this on the right by subtracting 3, and I'll get x is less than or equal to 7. Now I'm just going to quickly jot down a practice graph. I'll put my 7 to the left of 10. Now this is greater than 10. So I'll put a parentheses here, and I'll do that. And this is less than or equal to 7. So I'll put a bracket here and go here. We're talking about an and, so we want to include only the things that are shared in common. And there is nothing shared in common. So this is a null set. So we can write that for a null set. For this is the interval notation. And our graph, we just have our graph line, but nothing on top of it. So this would be the graph and interval notation. Number 22, we have negative 5x plus 1 is greater than or equal to 11. Oops, what did I just do here? Greater than or equal to 11. Or 3x plus 5 is greater than or equal to 26. So I'm going to start by subtracting this 1. And I'm going to get negative 5x is greater than or equal to 10. And then I'm going to divide each side by negative 5. Because I'm dividing by a negative, the inequality is going to flip directions, and we get a negative 2 here. So now let me go to the other side. I'll start by subtracting 5, and I'll get 3x is greater than or equal to 21, and then I'll divide by 3, and I'll get x is greater than or equal to 7. So when I sketch this graph as a practice, I put negative 2 here and 7 here. This one was less than or equal to, so it's a bracket and pointing to the left. This one was greater than or equal to, so it's a bracket and pointing to the right. Now, if this was an and, we'd have a null set. But this is an or, so we have to include them both. So in interval notation, what I write is I include the lower interval, which is negative infinity to negative 2 bracket, and I union this, that's the or, with bracket 7 to infinity. And infinity always gets a parentheses. So that's the graph, and that's the interval notation for this problem. Okay, number 23, we have negative 3 to infinity intersecting with negative infinity to 4. So I'm going to draw a quick graph. I'll just sketch something to help me here. I'll put negative 3 and 4 on the graph in order. Okay, so this first one is negative 3 to infinity. So it's a graph going this way. And this second graph is negative infinity to 4. So it's a graph that looks from negative infinity all the way up to 4. Now this is an intersection, so I only want the portion that they have in common. So if I graph this, I would clean up this graph and I would only include the places where there's a solution from both of them. So it would be like this. This is what the graph would look like. But in interval notation, I would simply just write negative 3 to 4. Okay, number 24, we have negative infinity to 6, and we're intersecting with negative infinity to 2. Again, I'm going to help myself by sketching a graph. I'll put the 2 to the left of the 6 because that's the way a number line goes. I'll do this in red. That's negative infinity to 6, so that's going to look like that. And this other one I'll do in blue. That's negative infinity to 2, which looks like this. And it's an intersection, so I only want the portion that they share in common. So if I cleaned up the graph, I would only include the 2. And it would look like this, because that's the portion that is shared in common. So in interval notation, I would have a negative infinity up to 2. I'm not going to include anything having to do with the 6 because it doesn't share a line. It doesn't share any solutions. Okay, number 25, we have 4 to infinity union 9 to infinity. All right, so I'm going to jot down a practice graph. I'll put the 4 to the left of the 9, and I'll do this in red. 4 to infinity looks like this. And then I'll do this one in blue. 9 to infinity looks like this. This is a union, so I want to include anything that includes a line from either one. And so if I clean this graph up, I would only include the 4. And it would look like this, because I need something that has a line from either one. So in interval notation, this is 4 to infinity. Okay, number 26, I have 1 to 2 unioned with 1 to infinity. All right, so I'm going to quickly draw a sketch of a graph. I'll include all of these numbers in order, so we really only have 1 and 2. So let's do this one first. 1 to 2 looks like this. And then I'll do this one in blue. That's 1 to infinity, which looks like this. It's a union, so I want to include anything that has a line over it. So if I clean this graph up, I would only include the 1, and I would go from 1 to infinity. So in interval notation, I'm just going from 1 to infinity. Okay, this is the second part, page 181, numbers 1 through 12. Okay, number 1, the rule you have to remember is if you multiply or divide by a negative number, you got to flip the sign or flip the direction of the inequality. Okay, number 2. Let's simplify both sides. So the first thing I'm going to do is I'm going to distribute this negative 6, and so I'll end up with 4 minus 6x minus 18 is less than or equal to, and then I'm going to distribute this negative 3. So I'll end up with negative 2. I'll distribute the negative 3 to get negative 3x minus 18, and then I have plus 3x over there. Now I'm going to combine like terms. So on the left, I have negative 6x, and 4 minus 18 is negative 14. On the right, the 3x's go away, and negative 2 minus 18 is negative 20. Now I'll add my 14 to each side to get that over there. So I end up with negative 6x is less than or equal to negative 6. Finally, I'm going to divide by negative 6 on each side. Remember, because you're dividing by a negative, the inequality flips directions and I get positive 1. It says to graph it, so I'm going to quickly sketch a graph. I'll put 1 there. Because it's greater than or equal to, we have a bracket. I'll do this in red. And I graph that way. If I'm going to do this in interval notation, I start with 1 and I go to infinity. It's a bracket on the 1 and a parentheses on the infinity. So that's interval notation, and that's the graph. Okay, number 3. I'm going to start by getting rid of my fraction on both sides. So I'm going to multiply by negative 7 over 4. And I'll do that over here, negative 7 over 4. On the left, it'll leave me with just x. Because I'm multiplying by a negative, this inequality flips directions to a less than, and then I'm going to cancel. 4 goes into 16 4 times, and I multiply to get a positive 28. So if I were to graph this, I'd pop a 28 right in the center there. It's less than, so I use a soft parentheses, and I'm going to the left. In interval notation, I'm going from negative infinity all the way up to 28 with a parentheses. So that's the graph and the interval notation. Okay, for number 4, the first thing I'm going to do is I'm going to get this negative 2 and I'm going to put it on each other side. So I'm going to add 2 to each section. And I'm going to end up with negative 4 is less than or equal to 4/3 x, which is less than or equal to 0. Oh, excuse me, not less than or equal to 4. 2 plus 2 is 4. All right, so now I'm going to, you can do this in 1 step or 2 steps. If you decide to do it in 2 steps, I'm going to start by multiplying by 3. I'm going to multiply each of these sections by 3. And I'm going to get negative 12 less than or equal to 4x less than or equal to 12. Okay, now I'm going to get rid of that 4 by dividing everything by 4. So I'll do that to all 3 sections. And I'll get negative 3 is less than or equal to x, which is less than or equal to 3. So in interval notation, I would go from negative 3, well, let's see. If I wanted to graph this, let's graph it first. I'd put negative 3 down here and 3 over here. And I'm going to put brackets because it's less than or equal to. X is greater than or equal to negative 3 goes this way. X is less than or equal to 3 goes this way. They meet in the center. So that's my graph. And in interval notation, I go from negative 3 to 3. Oops. And I put brackets. So that's interval notation on the graph. Okay, so for number 5, they're asking which one is equivalent to x is less than -3. So let's look at the first one. If we divided by -3, the inequality would flip directions to be a greater, and we'd have -3. So it can't be this one. Let's look at part B. If we divided by -3, the inequality would flip directions, and this would be -3. So that looks like what we're after. Well, let's just check the other two. If I divide here by -3, the inequality will flip directions, and I'll have, oh, I must have written down the same thing twice. Oh, this one is a +3. Oops. So this is going to be a +3, and that's not the case here. This one, I have 9 divided by -3 is -3, and that's the one we want. And so for the last one, if we divide by -3, we get x is greater than a +3. That's not it. So we're after part C. Okay, for number 6, part A, at least 7%. The first 4 dots on the left are all just, under 7%. So we could only be looking at the final 3 dots. So 1990, 2006, and 2000. So 1990, oh, that looks like, yeah, 1990, 1990, what are we counting by here? Tens. Yeah, so 2000 and 2006. For part B, less than 6%, there's only 2 dots that fall into that category, and it's the 1960 and 1970. And for part C, between 10 and 12%, but it doesn't say including them, between 10 and 12. So it looks like there's only one item that's between 10 and 12, and that's at the year 2000. Okay, for number 7, we'll say x equals the score on the 4th test. And we're going to add up all 4 scores, which are 83, 76, and 79, and this missing score. And to find an average, we'll divide all of those by the total number of scores, and that has to be at least, which means greater than or equal to 80. So I'll add up all 3 numbers there. 83 plus 76 plus 79. This is 238 plus x over 4 is greater than or equal to, oops, this was supposed to be an 80. And now I'm going to multiply each side by 4. So I'll get 238 plus x equals 320. And I'll subtract 238 from each side. And I'll end up with, oops, this is a greater than or equal to. That didn't change. So I'll end up with x is greater than or equal to 82. So this is at least an 82. Okay, number 8. What they're telling you is that the revenue has to be at least the cost. And they tell you that the revenue is 60x. And that the cost is 50x plus 5,000. So let's solve this for x, because x, by the way, is the number of items, the number of units of carpet. Okay, so let's bring this 50 over to the left by subtracting it. And I'll get 10 x is greater than or equal to 5,000. I'll divide by 10. So I'll get x is greater than or equal to 500. So 500 units of carpet. So this must be at least 500 units of carpet. Okay, number 9, they're telling you that A is equal to the set 1, 2, 5, 7, and B is equal to the set 1, 5, 9, and 12, and they want you for part A to find the intersection between A and B. So we're only looking at the things that they share in common, which are 1, they both have a 1, and they both have a 5. That's it. So for part B, they want you to do the union of A and B. Items that show up in either of the sets. So they have a 1, a 2, a 5, a 7, a 9, and a 12. Okay, number 10, they're asking you to solve x is less than or equal to 2 and x is greater than or equal to 2. Well, if you think about this on a number line, x less than or equal to 2 is a graph that goes this way. X greater than or equal to 2 is a graph that goes this way. And if you put them all together, this is a graph that covers everything. So in interval notation, we would say negative infinity to infinity. And if we were to graph it, we would use a graph looking like that. Okay, number 11, we have 3k is greater than or equal to 6 and k minus 4 is less than 5. Okay, so on the first one, we're going to divide each side by 3 and we'll get k is greater than or equal to 2. And the second one, we'll move the negative 4 over by adding it, and we'll get k is less than 9. So if you think about a graph, let's put our 2 to the left of the 9. All right, if we do this one in red, this is a greater than or equal to 2, which looks like this. If we do this one in blue, a less than 9 looks like this. And we want to share only the portion that they have in common, which is this area right there. So we would write a cleaned up graph. We would only include the 2 and the 9, and we'd put a bracket on the 2 and a parentheses on the 9, and it would look like this. That's the graph. In interval notation, we would put a bracket for the 2 and a 9 and a parentheses, and that's what we would have in interval notation. Okay, finally, number 12, we have negative 4x is less than or equal to negative 24, or 4x minus 2 is less than or just less than 10. So in the first problem, we're going to divide by negative 4. Remember, because we're dividing by a negative, the inequality flips directions, and we get a positive 6. On the second one, we're going to move their 2 to the other side by adding it, and we'll get 4x is less than 12, and then we'll divide by 4, and we'll get x is less than 3. Now, if we sketched a graph, we'd always put the 3 to the left of the 6, because that's how a number line goes. Let's do this in red. Less than 3 looks like this. Let's do this in blue. Greater than or equal to 6 looks like this. Now, if this were an and, we'd have a null set, but it's an or. So we have to include both of them. So we're going to do negative infinity all the way up to 3, and we'll use a parentheses, unioned with bracket 6 to infinity. So that's the graph and the interval notation for this problem.